Good afternoon, good evening, everybody. Welcome to the Hunkeberg campus of the ETH, the Swiss Federal Institute of Technology. It is a real pleasure for me to be able to welcome you here in this incredible building. How many of you are here for the first time? So this half is here for the first time, and this half is not. So, okay, that's an interesting mix here. I had the privilege of going to school here many years ago, and this building didn't exist. It was just the brown one you walked through to get here. And it's interesting to me to see this structure as a manifestation of where we stand today and where we're heading. And that was a manifestation of where we were when it was built at the same time and when it was built. When we look around and see this incredible form, which could not have been created without computational tools, could not have been created without a very real and meaningful collaboration between the designers, the contractors, the owners. And now we're going to be talking this evening again about a project which depended upon that kind of collaboration, which this beautiful space also represents for me. And now this is the heart, in many ways, of our university's research on, I would call, the future of the built environment in many ways. So my name is Chris Lubkeman, and I have the pleasure and the privilege of leading the Strategic Foresight Hub in the Office of the President here in Zurich at the university. And my job is to help us think about what we want to be when we grow up as an institution, actually the next 20 years, if you will. And probably most importantly, I'm your host for tonight's conversation. Timber, concrete construction, is hybrid the new normal? This is part of the series of the Holcim Foundation Awards Talks, which is, you know that, which is why you're here. The aim of this series is to be able to have a deep dive into emerging design and construction practices that could be the key to driving positive change in the design and construction of the built environment. For those of you who don't know, the Holcim Foundation for Sustainable Construction was founded in 2003. It's a nonprofit organization whose mission is to support sustainability, change accelerators. I'm supposed to say that quicker together, okay. Sustainability change accelerators. Hey, I know, I'm human. In the built environment. Its international awards program has recognized over 250 teams of architects, engineers, and planners in 70 countries over the years. And there's a little white book, which some of you I see have in your hands, which is down on the table there, and the website has the incredible collection of the projects. The projects are rewarded and rewarded for their contribution to the Foundation's goals for sustainable construction, which include their environmental footprint. I had dinner last night with Matthias Wackernagel. He's here in Switzerland right now. He's one of the co-founders of the ecological footprint method. He's a Swiss and an ETH alumni. A little bit of pride there. You can feel that. That's all right. You're a tough audience tonight. Sheesh, been a long day? Yeah? And for you too, a long day on this side of the room? All right. It also includes, in the awards, looking at the social impact and economic sustainability of each project. And last but not least, the way in which the intervention impacts a place from a contextual and an aesthetic perspective. Winning the Holcim Foundation Award has enabled many teams to accelerate their impact, and several winners have gone on to be recognized internationally. So I'm actually quite excited to be introducing an award winner to you tonight. And it's interesting because Roger and the team, and the whole team, we'll see here in a minute, have put together a project which we're going to see right here, which is really beautiful. And I must confess, I didn't know about it until I saw the awards. And I'm a huge fan of concrete. My PhD was in concrete. I'm a huge fan of shells, and we're in a shell. I'm a huge fan of hybrid and the future. So it's for me, being able to host this tonight is a real pleasure and an honor to see what's happening and exploding as we move forward. Now, our time together is going to be about 60, perhaps 65 minutes. You will have a chance to ask questions. I will be inviting the panel up right after a short little movie clip, and then we're going to have a dialogue for probably around 20, 25 minutes. And then the last half hour will be a chance for you to ask questions. Okay? Now, I'll say that a few times. I can sit there and talk with these guys forever. I mean, they're so cool. It's a really cool project. But really, we really want to know, what are your questions? So be thinking about those as we go. So you ready? Oh, come on. Let's do that. Are we ready? Yes. Oh, man, the second row over there is just sleeping. You guys are dead. I see it. Okay. So we're going to get started. Can we roll the movie? And we'll just take a look at the project.
The Wholesome Awards Acknowledgement Prize for Europe goes to the high-rise H1 SWAT site in Regensdorf near Zurich, Switzerland. The hybrid high-rise low-tech housing solution project is led by Roger Bolthauser of Bolthauser Architekten. The residential tower will be part of a new district development to accommodate the Zurich region's growing population. The tower of flexible modular apartments for around 2,000 residents concentrates density to reserve land for well-structured outdoor spaces that are connected to the surroundings. The Wholesome Awards Jury for Europe praised the harmonious combination of timber structural elements with other materials, such as concrete and clay, and the remarkable integration of the building within the urban context.
Fantastic. So, if we can have the team come up onto the panel. Come on up, come on up, come on up, come on up. Here we go. Anna, Andrea, Anna's here, Roger, and thank you. Okay, so first, we have the microphones all working. Cool, okay. So first question, I'm going to ask you to introduce yourself. So Anna, who are you? Just very quickly.
Thanks. I'm Anna Alberati. I'm architect, actually. I worked for about 13 years in an architectural office before changing to real estate. So now I'm working for Pensimo Management. It's an institutional investor. Our clients are pension funds, mostly. And we have many residential buildings throughout Switzerland, but also abroad. And my task as a portfolio manager is to invest sustainably and to keep this long-term approach, actually, on the whole entire value chain. Yes.
Great. Thank you very much. And next, we have
Andrea Frangi. I'm a structural engineer. I study on the other side, long time ago. I've done the PhD, then I have been working in the practice in Canada, in Switzerland, and now for the last 14 years, professor here at ETH for timber structure.
So you're Mr. Wood.
Yes and no. I mean, today is hybrid, so maybe I will say also something about hybrid. No, I'm at the Department of Civil Engineering, I'm focusing on wood. Yes.
Awesome.
Mr.
Great.
Wood is fine, thank you.
I'll call you Mr. Wood rest of the night. Okay. Roger.
Yes, Roger Bolz as an architect. I study also here at the ETH. I start my practice after being an assist here at the ETH and also at the ER as a design chair from Peter Merkley. Here at the ETH, I start my practice in Zurich. Today we have an office also in Munich, and some project also out of Zurich, and I'm a teacher. I have a chair here since also at ETH after being in EPFL and TU Munich here since 4 or 5 years. Yeah.
Great. And you do not only wood, but you do many different materials.
They're often hybrid.
Often
But
hybrid.
I start more with the earth research. So my research is based on earth construction.
Okay.
And this is mostly hybrid. And we have also earth in this project. But here is another combination of material.
Great.
Yeah.
Thank you. And last but not least, a man who actually made it happen, who put it all together, Thomas.
Thanks, Chris. Thomas, I studied wood technology 30 years ago. Then I made business administration, the Master of Business Administration, and do 8 years engineered timber projects, those are very special projects. Built also the roof a few years ago. And since 20 years, I worked to Erne or by Erne. And also 20 years ago, we start with wood concrete composite elements at Erne. With my beginning, we start with the wood concrete composite elements.
And for those who don't know who Erne is, what is Erne as a company?
Erne is a wood company, part of the group. We have also a concrete company as the main company. And today we are at the same level, the concrete company and the wood company. So, yes.
Fighting up there.
It's like a fight, yes.
Great, thank you. So next question for all of you. Why are you on this panel? Anna?
No clients, no projects.
Very
simple.
So you were the client for this project.
That's right, yeah.
You funded it. Why?
Yeah, I remember this competition 2019, I think it was, and actually we weren't sure at all which kind of project we are looking for, but we were really convinced by this solution, hybrid solution, because we were thinking our strategy is to reduce CO2 emissions, and we saw really a huge potential in this project, so that's why we chose it.
And so when you say you saw huge potential, what potential? I mean, because you like to hold assets for a long time, right?
Yes.
You don't flip. You keep. So was that an aspect that you saw in this that you liked? Or what other things?
Yeah, we are aiming long-term investments, and at the end, it's like we are also looking. Our investors, they're also interested in many sustainability aspects of sustainability, also ecological ones. So it's a big deal when you think about, okay, how can I reduce emissions during the producing something, or how can I restore also carbon dioxide for a long term? So that's the chance that we saw in this project.
Okay, so I want to go to Roche. You know, when you were designing this, when you heard from the investor, you went to her and you said, what project do you want? And then you made it for her. Is that what happened?
No, it was a competition.
Okay, so it was a competition.
Yeah.
And tell us about what was from the design, what were you wanting to achieve and why?
Yeah, so in the competition, in the text was clear it should be climate is an important aspect, but they didn't ask for a wood tower or a hybrid tower. They just asked for interesting answer, and we was the only one who has this idea of a hybrid tower. Nobody else did a design with wood. The other was more conventional or have other ideas about to work with the CO2 balance. But in that time it was 2019,
I think. 2019.
a little bit earlier. So there was just the beginning of a time which designs was more and more goes with this climate aspect. For us was one of the very first project in hybrid in wood. We did a competition before together with Hermann Kaufmann, who is the wood engineer in the TU Munich, because I was also the TU Munich. We was there also third, fourth, and then we did some mistake, and we thought, okay, maybe we have a good client here. Maybe this is a chance to do it really good, and then we had this idea of this hybrid construction.
Okay, so tell us a little bit more about, for those who have never been to it, tell us a little bit more about the project. What was it? How many floors? Give us a few stats and.
Yeah, it's it's hybrid. It's concrete and wood. We have 3 stories which is in concrete, because we have a structure which is after 3 stories. It's more public level, so office, and then we change the structure to a wood structure which is more dense, and then we start with the house with the flats and the housing concept, and there we only have a kind of inner core in concrete, but the rest is really wood. So in that sense, is a hybrid structure. The project, the problem we had in the last project that we came down with the wood structure. We have not really a public space dancer because it was so dense, the structure with the columns, that it was not a nice entry situation. So we want to do something which is, in one way, was more relaxed. So the project was more a hybrid construction, but on the other hand, the structural change of tree level makes the design also more interesting and in a way more efficient, and you can say every material is at the right place. So it was a kind of make it simpler, but in a way also more interesting and better. So, and this we try in this famous model, which you have the concrete base, and then you take the wood head away. This was the idea, and this goes.
Let's hold on that thought for every material at its right place.
Yeah.
Right. I mean, Andreas, as not just Mr. Wood, but what does that mean when you hear that? What does that say to you? Every material at its right place when it comes to hybrid.
I mean, we should respect really the material for its performance. And in the first 3 floors, they have large span, huge load to transfer from the upper part to the lower part. I think the reinforced concrete was the right choice. I have no problem. And in the upper part with the small grid and so on, it was really also designed for another material, and timber fulfill perfectly this performance. So that's I really think we have, of course, we would like to do everything with wood, Mr. Wood, but we know it's not possible, and we switch to other material when wood does not work. Yeah. Statically speaking, or for other functions, there are many reasons for choosing the right material.
So what does hybrid mean for you? When you see the word hybrid, you mean, oh, okay, that means this or this or this?
Yeah, we distinguish. I mean, hybrid because in this building you have different material, and composite because sometimes we really take concrete and timber work, structurally speaking, together. It's not there. So we are really combining different material in a structural system. The slab, the floor, is made by beechwood and concrete, and they are working really together.
Okay, so the floor slabs are beechwood and concrete together?
Yes.
All right.
And what we call the composite system. Mm-hmm. And then we try to use the advantage of both material by combining these two. It's not that they are working independent. They have to work together, and they work together.
So that's the composite, and that's the Verbund.
Yes, Verbund.
You'd say, right? And so is that? But there's other hybrids happening, because you mentioned we've got a concrete core, and then the columns are solid timber. Is that correct? I'm looking at you too. So.
That's correct, but I mean, hybrid for me is when maybe you have a concrete core, and then you have maybe a steel frame, and you have a timber floor. So I do different elements with different material, but none of these material are working together. So then it's a hybrid structure, but structurally speaking, no composite element are used, but it's already too complicated.
No, that was good.
This
is a smart audience, man. They're with you all the way, totally. Yeah.
And if you think how many material we have in this building, insulation and so on. So, I mean, we are always talking about 4 structural material, but then there is so many material in this building.
So, Thomas, for you, hybrid, because you're quite proud of the hybrid. Tell us about that a little bit.
So for me, hybrid is to combine, Andrea said it, the advantages of the different materials to reduce the disadvantage of the other material. So So at the end, we have a good element. If we talk about composite elements, we have the best element. We combine the advantages of all these materials. Other thinking is about hybrid system or hybrid buildings, that you build the buildings with the material you have on the earth at the end. That's wood, concrete, steel, and clay. So when we combine these materials in one building, we also talk about a hybrid building. So that is my understanding or my meaning about hybrid system, combine the advantage of the materials in an element, or build a building with all the materials we have in one building.
So what are you, Thomas, most proud of when it comes to this building itself?
This building have, I guess, 3 challenges. That is the height. We have beach. It's one of the first building we use beach in a composite element.
It's the only.
Okay. I want to say so directly, but so that is one. And at the end, the challenge is that the prefabricate element and beach at the end don't want to see any water by assembly this building. And that was the 3 big challenges that we have find solutions for that.
So they were prefabricated elements.
Yes.
Okay, and you craned them in. And what were the elements which you prefabricated?
We prefabricate the elements in the factory in Stein.
And which elements did you prefabricate?
The floors.
The floors.
The floors.
Okay.
So with the beach beam and the concrete on top of it. And then we bring in the connection to combine these 2 materials to one element.
Yeah. And I know from my previous life that connections are very often the most difficult part of Verbund, of prefab. On this project, what were some of the solutions that you came up with to make sure those connections really worked and are going to work to make her happy in another 100 years?
Yeah, that was one of the challenges, but we use one connection from Decomtech. It's a metal sheet we glue into the wood, and half of them is glued in the wood and the other half is in the concrete. And the challenge for that is that this connection is regulated only for spruce.
Only for spruce?
Yes. So for that we have to do some tests with beech to look, does it work also in beech?
And it did, obviously. Otherwise,
and ETH and Andrea Franchi have done this.
And so you did that over in the lab here.
Yeah, there is only one problem, that we have done the test, but meantime the building was built. So,
oops.
oops. But we have so good structural engineers, architects, and investors they trust, and the test confirmed that it worked. If the test would not confirm this, I don't know, because the building now is erected. So.
And did you know that was going on?
No,
Sure,
but
sure, I knew it. Oh, come on.
but this is the strength of Switzerland.
Yeah.
This building can be built only in Switzerland due to the investor and company and architect and engineers we are supporting, and we are taking the responsibility, because if you go to Germany, no chance. This is a wood beach composite floor, as we have done in this building. No other country would accept, because it's something new. Nobody knows how this element works.
Okay, but now it's up. Now it's up. The prototype is check, right? We have happy family, right? So what about this future of this combination of beach, of concrete, of wood? Roger, where do you see the future going with this?
I think we have to, it's clear we have to deal with CO2, we have to build with less CO2, and if we have wood, and if you want to do smart building, you came to a smart hybrid structure. And I would say the future is there, where you really have wood. Switzerland has a lot of wood. In Germany, we have parts. We have which has wood. Other countries have no wood. I would say there are other answers, other hybrid structures which they have to develop. But I see a big chance with wood, especially in Switzerland, and also other countries where you have this material. And we should not burn it. We should build with this material.
Yep.
And storage CO2 too.
Yeah. So same question to everybody. I want to add, what about you? Would you do this again?
Yeah, sure. Because I think one more aspect of the hybrid construction, and a positive aspect, is the possibility of reuse. So Thomas, you can explain it much better, but I think you can take out, separate all the elements, or mostly the elements. So at least the reuse is also possible. So it's a big deal. So yeah, I've never regretted this decision to support this project, and I would definitely do it again. And I think today we know much more than we knew before in the beginning of the project, where we also as investors took a big risk. But we trusted the process, yeah.
That's great. And I also liked how you're advocating for the reuse. It's anticipation, disassembly, perhaps is still your asset. This is like a material bank, which you could potentially look at in the future. And she referenced you, Thomas. How can this be taken apart for the reuse? Because lots of composites you can't reuse again. Like composite facades, you're stuck.
Yes, the composite is not so easy to trennen,
to separate
the materials. But what we can do is use these elements. So when we can build back these elements, we can use it in another building. So, but for that, we have to know what are the requirements, or what are the rules for these elements, what are the forces, what the quality of the element, and so on. So, and we made this in the building. We have each knot of the building documented. So we know the material, we know the quality of the material, we know the quality of the concrete, and we know the quality of the connection. So for that, if we can bring it out of the building, this element, this composite, then we can reuse it as an element.
When you were designing it, did you think about this? I'm actually just curious.
Not today.
Okay. Yeah.
So that is the big challenge for the next. So, but for the future is what we see today is sustainability is going on. So construction like hybrid system works more and more, and we see more and more projects who build with this. And the next question is, can we build it back for disassembly? So the new word is designed for disassembly.
Yeah.
So
it's a new thinking. So Andreas, I want to ask the same question you asked before about the future. When we're looking forward, where do you see this combination of timber concrete or hybrid heading? Where do you see this? This is.
I assume in a few years. I don't think that we have to wait a decade. This will be the standard.
A new standard.
Not yet. I mean, the standard in the way this will be the solution. I have to pay attention what I'm saying. But for me, it makes no sense to build any more reinforced concrete flat slab 30 centimeter thick to accommodate the pipes. And this will be in, 10, 20 years, the history. And we will go to other system. With concrete, no problem, but with less concrete.
So what about with this, you mentioned pipes. It makes me think of other regulations which sometimes are, when we look at timber, we get concerned about, which is fire and noise. With this construction, how is this panning out? With the fire and noise transmission, as an owner, or do you have complaints? Are people happy? tell us a little bit about that. Fire and noise.
Yeah, that is the big, how can I say, this is the big problem that we have if we talk about timber construction. Fire is a big problem. Normally everybody means, oh, that is a big problem, but normally wood is the better construction material in a fire case. And for the noise, that is a big problem in normal timber buildings. And also for that, we have these composite elements, so bring all these advantages from the concrete, the weight, into the building, combine it with the wood in a Zug tension, and eliminate the steel or part of the steel in the concrete. Yeah. And that is the best sustainability element I know.
Yeah.
Reduce the steel in the concrete, and combine tension and weight and fire resistant in one element with the composite of this.
Any other thoughts on this? You just let it go. Come on, Andre. Raise this one.
No, of course. I mean, this building fulfill all requirements. Of course, otherwise we cannot build fire-resistant, sound insulation. And this show that you have also other solution to fulfill the requirement using much less material. At the end, this building is also much lighter than a conventional building. Bringing probably advantage in foundation and so on. And also with regard to building system, now maybe Roger mentioned, it was also mentioned, maybe we don't need too much building system in the future. Also low-tech is more than enough. Then we give the architect and the investor order, and maybe there are, yes, I mean, and the sprinkler is also visible. I mean, it's also interesting. And the sprinkler is for the fire safety the best what you can introduce in a building. There will be never a fire in Swat. I mean, there will be, but it will be extinguished immediately. And you will not have damage, and people will be happy. So I would never build a tall buildings, regardless the material, without sprinkler.
Yeah, of course.
It's the best system.
I hear you. So, because I ask you because I for 20 years been hearing about how this danger, but actually we know that this is not the case because we now have the solutions. We know that. Now, what kinds? So you mentioned beech, and you mentioned spruce. When we look at this sort of timber concrete, I'm quite curious. Did you look at other combinations, or did you land on that because there's this like a shipload of beech which you needed to get rid of, or how did you? Where did you land on the materials, and what are the best ones for us to look at? Bye. Mr. Architect?
Yeah, so I came from earth construction. So earth is also very simple construction. So, and if you have to build higher, or if you have to build slabs, you have to do hybrid structure. Even if you look into the history, also earth building was often in combination with wood. So you see, you can save a lot of CO2. You use every material in the right place. The history shows us that. And now we look for answers, and we also have a flagship research project here at ETH, which I'm part of it, which we exactly do that, wood and earth. And from that case, it's clear that you look for solutions, and also if you go with other material, that you look for smart solution, which you could save energy and do it smarter. So I think it's clear that in every combination, and it could be wood, but it could be also earth or other reuse material. It's a smart thing to think in hybrid. Hybrid is also intelligent if you prefabricate, and you can start to think circular, that you can reuse the material. So it's anyway a smart solution. I learned it with earth, this aspect, and first of all, we want to build it in earth, but it's already the highest wood building now in Switzerland, so in earth is not possible. So we had to do something hybrid. We have still a little bit earth in it, in the base, but yes, it's clear that you look for other solutions. So we came to that, yeah. And it's maybe to add to the discussion, we integrate the EPFL startup Fagus. We did the beach is a kind of block system, which is glue. It's not a laminated wood. And this is also new in this dimension. It was also to test that if this really worked, because you have 5 times less glue in it. So it's also innovative that you have, so you correct me if it's, but it's around 5 times. Less glue, so it means less CO2 in. It's good. And the thing is the columns are really wood on all sides. If you have laminated, then you see glue and then you see wood. Yeah. And this is also happened. So we have a P facade which is looking for, gives the building 50% of the energy. So we did nearly everything we could to have at the end less energy in the building, and really was also for us was as architect interesting. First of all, it was an interdisciplinary thing. So we couldn't find the solution for ourselves. We had Schmetzer Puschkas, we have wood engineers, we have Andrea, we have many engineers who help us during the competition to make it possible. So it's a very flat way of designing. It's not as we study here at ETH that the architect say how it should be. Without you engineers, you're not able to do that. Yeah. But what is also interesting is that you come to, because you take these problems seriously, you come to other solutions. Yeah. So the language is different. Yeah. And now you have a wood column in your flat, which is extremely nice, you know.
Beautiful.
Beautiful, yeah.
You bring up something which I wanted to move to before I come to you for questions. Does anybody have a question yet in their mind? Harry has one. No, you have to, okay. Stuart has one. Anybody else? There has to be 3 before we go. Okay, so we'll keep going here. You mentioned something about the team. I wanted to ask about this. Any kind of, when you're doing this kind of a project, this hybrid, especially with timber, concrete, 2 materials, and many of us from different worlds, does it require a different mindset? Probably yes, but also team structure, different tools, different way of working. How did you find it? This is not the only building you've ever done.
No, it's not. And I remember our discussions. We didn't want to have this chalet feeling in the apartments. And the other thing was dimensions of the columns, because losing the surface, it's it was so interesting. So that was exactly the time when you came up with this suggestion to make it out of beach, of these blocks, and with Fago Swiss. Yeah.
And so that implies from a design standpoint, a lot of conversations and interaction, not just you saying it's going to be this. It's like, okay, you don't like that, okay, I could do something else. But was there other kind of tools? I'm just kind of curious, or tricks. If someone in here wants to try to work on one of these or do one of these starting next year, what kind of advice might you give about team structure? Or, again, I come back to tools, digital tools or something like that. Any suggestions or advice? Any of you? Roger?
Yes, so it was already talking about that. It's first of all, it's a very flat structure. It's not that the architect has a big idea and then I want to do a wood tower and it's like that, and then I go to Andrea and ask, can you do that? And he said, no, it's not efficient what you do. So and if you today you also you can't win a competition. So it means if I design something, I'm directly in dialogue with Andrea, sometimes also with construction company, but also with the building, with the house technique, with all these aspects. Because also here you have to plan it and to integrate it, and the fire and everything, you have to bring the solution. And this is another way of designing. Mm-hmm. It's not a top-down thing. It's an integrated thing. And the funny thing was, we start to have in the competition meetings with 20 engineers, and Zoom was helping us a lot, because you have them for a half hour, you have them together, everybody was discussing, wants to make it possible, and gives you the idea what you have to check and do, and then the design also change. And this is something which you, as architects, as designer, you should be able to do. Otherwise, you don't have the numbers behind. It doesn't work, and it's not efficient. And if you want to go in this with these topics, it's a much more flat process.
Okay.
And this is completely different to the time I study here.
Go ahead, Anna. Do you want to add something?
Yeah, I was just,
you want to say something? Come on.
I was just thinking about this time because we took a huge risk as investors in buying a material before we started to plan concretely. You remember this time because we
buy Swiss wood. We have to say it's real Swiss. This is also something special.
Yeah, this is Swiss wood. We wanted exactly this product, and for that you had to organize it. We were like totally afraid that we are not going to be able to get a material and that's why the timber engineers, they had to work much faster. They had to deliver all the measures, everything that the Fagos needed, so that Fagos would be able to offer us to give us an offer for this material. And our investment committee was like, "Oh, are you crazy? What are you doing? You are buying material before you start the project, actually." So, yeah, that was.
It's the new process.
It's a new process. Yeah.
So, how do you see this? Did you know they were buying the material and you're going to put it together? And
not really. What I can say to that is that yes, you need a new process for building these projects at the end. You need a client and an architect who is able to adapt all the inputs who come from the company, from the producer or the assembly.
Yeah.
And also we have to accept that discuss about all these solutions or requirements. They come from an architect or from a client. So we are only the constructors at the end. And that means at the end that everybody is part of the team and everybody should be able to hear what the other partners say, and adapt this or discuss this in an open space at the end.
So it's a real partnership, what you described. It's a real partnership.
Yeah, everybody in the team wants to bring this or build this project and bring this to an end at the end. All are proud of this project, I guess.
So it sounds like it was sort of fun to do. Was it fun?
It wasn't easy the whole time. So
it was fun.
It was fun, not easy.
We also have hard times.
Yeah, that's right. No, that's good. You go through hard times, you can laugh about it afterwards when you have a beautiful result. Andrea, and then we're going to come out to whether be questions.
I mean, I really, at the beginning, I was more hired by Anna as consultant because probably they didn't trust timber. Then I switch and I help architect engineers to develop the system and so on. But nowadays, as far as I know, that SFAT is the most visited building after maybe the Fabrik Chocolate in Kielberg. So
really? No kidding.
Really, you have to stop.
It's incredible. We have the whole logistic is all about visits. We have visits from all around the world.
You have more visitors than Mitarbeiter
on the side.
That's crazy, and that's cool.
This is really cool. I mean, we have a lighthouse project, and in few years, in Switzerland, we have more tall timber buildings or hybrid tall timber buildings than all over the world in comparison maybe to population and surface.
That's great. I like that statement. I'm not going to fact check it. I'm just going to keep it. I'm going to keep with it for that. We're going to go. Okay, questions. Is there a mic or do I use one of these up here? And then, well, I'll just take one right here. I'll run. I don't mind. I'm kind of straight. We got 3 questions. Okay. Here we go. You've got a mic here too. So, Harry, you put your hand up first, and Stuart, then I'm going to come over to you, right? Okay. So who are you? Just first of all, say who you are.
Okay.
My name is
Harry Gugger. Have worked with Erne also on such buildings, such composite structures. And I fear you didn't make it clear the beach business. I fear you have to explain a bit further. For the columns, it's understood because you need that hardwood to cope with the load. But for the composite slab, why beech and not spruce? Because we did the same system with spruce before. Is it the span which requires the beech, the hardwood? Because we heard it's not the fire protection. You have a sprinklered building, and so is it the span which is a bit larger than normal, or did you try to save on glue? But you said you still have glue; they are glued, these elements. So you have to elaborate a little bit more on why beech for the beams.
Cool. Good question. Go for it. Come on.
Okay, one thing is the span. We have a very long span, up to 9 meters, I guess, 8.5 or something like that. And we have to optimize the height of the element to the floors of the whole building. So, and then with spruce, normally you have the cross section is maybe 30% lower than spruce. So.
But it's not massive, it's still cross-laminated.
It's the same from the Fagus with the Stabbuche.
Blocks.
Yeah, blocks.
And of course, I also like it aesthetically to see. And we didn't talk about aesthetic, but I mean the beautiful, you know.
Yeah, you can see them right there. Right? I mean, this is
The color. Even these are renderings, but
okay. Yeah. There's more than 30 here. Okay, Stuart.
Thank you very much. I really like this project. I think it's very beautiful and fantastic use of timber concrete hybrid. I have lots of questions, but
I'll get you. You get one.
I'll get one. I know I get one. I know.
If no one else has one, we'll come back
Exactly.
to you. Okay. Yeah.
I'm a structural engineer. Chris mentioned being Mr. Concrete and Mr. Shell. And as I walked through the door, of course, I know the work of Philip Bloch very well, looking at concrete shells. So if you just took the concrete from this, you could eliminate the timber. And so, and I think already timber concrete composite is the new normal. There's lots of schemes on the drawing board already. So do you see the potential to evolve without the timber? Do you think Philip's kind of going in the wrong direction? Did you look at that as an idea for the project? I'm kind of interested in what we might do next, and particularly as we have such a reference just down the corridor.
Interesting question. Yeah. Does everybody know what he's talking about? Yes. I'm just looking at the heads, Thank you. Okay.
Yeah, I think to have more efficient concrete construction makes a lot of sense. So, because we have colleagues of mine, they told me, Roger, you saved 25% of CO2 because you did it not a normal concrete structure, and you did a hybrid structure. We can do the same in concrete. And I said, oh, great, yeah, you really can do that. So let's do it. And we also have a project with Philip Bloch in Zoo of Basel. We did a competition together, and we hope we can go on then. So I think it's any material you can optimize, and at the end use it in a hybrid structure. It makes sense because this is what we have to do. You was asking what we should optimize every material and use it at the right place. And if you have new ideas to make, I don't say I'm against concrete if it's really in a smart way or for efficient fundaments. It makes sense, and it could be also maybe the wood provoked a reaction to the concrete industry with new systems which are very light, close to wood. So this is great, I don't think that this could be another way. Every material has to do his job in our times,
Yeah. Andre, do you have a response to Stuart's question?
I mean, we need both solutions, or we need also new solution with concrete, and Philip is promoting new solution. And I repeat what I mentioned. I don't want to see anymore a reinforced flat slab 30 centimeter thick. But the slab of Philip has probably, 50% less material, then is the right direction. I'm really a fan also of this solution.
And some of them are in combination with earth. So, so again, hybrid.
So, and I'll take my moderator hat off for just a moment and stand with the crowd. It's also interesting to think around the world. Some places have a lot of wood, some places don't. And so it really comes down to the contextual parameters of that site and the where we can be doing it. So to me, it's yes and much more. That's how I think of that. Because in both great solutions for different parts of the world. Yeah.
Yes, as what you can do, you have to go in each country and look for the culture they have, building culture, then you know what kind of material they have, and then you have to find out a smart solution for an upscale. It's all about upscaling.
Yeah.
A traditional solution, we have wood, so we think about an upscaling. Maybe you need concrete, you think about an upscaling, or you have earth, you have other things, and then you start to think what you can do with that.
Great.
Stone.
Thank you.
In Mallorca, young architects try to work again with stone.
Yeah.
It is a tradition 100 years old, but forgotten. Now they start to build in stone again and do walls also.
Back to the future. Yes, ma'am.
Not really, man.
Yes, ma'am.
So, building upon actually what you were just saying, it seems that many of these new construction systems can become the new normal in Switzerland, indeed. So that in Switzerland there are an ecosystems that allows for these experiments, let's say, and these new strategies to be implemented in a way. But then one of the first things you said, this building was possible to be built in Switzerland only. So the question now for me is how to make these solutions more transferable elsewhere. So what are the barriers? Is it just a matter of regulation, of regulatory frameworks, or is it it's a matter of processes? So this is the question.
That's good. Good question. Who wants to go for that?
At the end of the day, regulation will change the game, yes. And if you think what Europe is now introducing and so on, in 10 years you will not be able to build any building which is not sustainable. Then we have to discuss what is sustainable, how we have to quantify, because the investor cannot do anymore put money in this kind of building. So yeah, and this is the role of Switzerland. We want to show what is possible, and we hope that many countries will catch up. And unfortunately, some countries have they don't understand that it's important to allow some experiment in the construction sector. Otherwise, we will never progress. And in Switzerland, we have this special situation, and I always say, which country can do this? Only Switzerland. We have money, we have
smart people, we have great contractors, good architects.
Liberalization and Eigenverantwortung.
Yeah, but it's also, what it means for the other country. We need examples. And out of that, we have to create norms that it's possible to build in Germany. In Germany, with earth, it's the same problem. We can build earth building here easily, but in Germany, we need die Zulassung im Einzelfall, which means a lot of money, and it's only for one building, and even if you already build it. So also Germany is working on norms for earth construction, and it will be the same in wood. I would say this building is possible in Austria. It's not in every country the same, but we need example, which we can prove, measure and have results to make or norms out of that. It means it's exactly what we have, maybe a little bit better background here, but the end must be that we can have norms that everybody can build with that and everybody could accept. And at the end, every country wants to do it. It's just maybe they have different backgrounds and a stronger regulation, but at the end, also Germany has to do it, and they will do it. There's many schools who really works on that. TU Munich and Braunschweig and many smart schools.
Okay. Yes,
Can I say something more? So we build a lot of buildings also in Germany, also in wood, concrete, composite elements. So the problem is not the ceiling or the floor. So we have the we have the tool for do that. The problem is not the column. The problem is when you bring the column and the ceiling together, nobody knows how this works. And everybody say, oh. And that is the big problem today. So we have regulations for the ceiling, it works. We have the regulation for the column, it works. We have regulations for the beams. But when you bring all this together, then everybody says, oops.
But now you know how to regulate.
Yes.
You can tell them.
Yes, now we can tell them. It works.
But it's an interesting question, the export of that, to contextualize into other places. It's a really good question, and not a simple one. There's a question back here. Who else? There's one right here, and then back here. So you up here up front, and then you in the back. Here.
So,
go ahead. Yes, please.
hi. So my name is Jeanette Kuo. I'm also an architect here in Switzerland. Thank you for the very inspiring project. And I think I understand, of course, also operating in this environment, how lucky we are in Switzerland to have people that we can work with that really take the risks with us, right? So the four of you up there, obviously, as a team, made this project happen. And I think what my question would be is, and what I'm curious about is how it was for you as a permitting process, because you were talking about doing the testing and then already the building is being built. And so how that actually worked with the city, getting the permit of it, because it seems like it's been quite smooth, everything moving forward. If you had to do anything special to convince them, how you kind of got through all of that with something that actually is quite new and innovative.
Okay, and with that, would you do something different, looking back? Was it easy to get through, or was it a pain?
No, you need the engineer who sign in Switzerland, and then you can build it. And then it's, in a way, only the client who say yes or no. The Regensdorf never told us, don't build the wood. They was proud to have the highest one, probably. For the next 3 years, probably there will already come the next one in 80 meters. I think this is the good thing. Switzerland really trusts their engineers or their expert, and so this is really, in that sense, was not a hard thing. The client has to be sure, and this was but they was with us, but they have critical question. This we have to do.
Yeah, and at the end, I mean, the project still has to be affordable for the tenants in Regensdorf, because we are not building here in the middle in Zurich where we can ask for any rent. So that's the quality also of the project, because hybrid constructions, timber constructions, they need more volume, and the increasing of the volume increases the costs. But the floor plans, I mean, if you look at the floor plans, they are really optimized. So that's how the apartments are going to be affordable for somebody in Regensdorf.
Great. Excuse me, we have a question in the back, then there's one over here.
My name is Remy. I'm working with Roger Bolzhauser at the chair, and I'm interested in earth construction. I was wondering if we could hear more about maybe a slab that could be out of earth and timber. Like, a lot happened these last years. We have Hortus, for example, that is this vaulted rammed earth slab, and then Erne is also doing this big vaulted rammed earth slab with timber. And I wanted to hear your opinion on that, if you could build a high-rise, for example, also with that, or even with poured earth combined with timber, if that could work.
I would say the slab system from Herzog Dömerow, it's possible also in a high-rise building. We have another little test we want to do. In the SWAT building, we want to do, I don't know in English, Unterlagsböden in earth, which is also, think about that all the cement-based floors, which are 6 centimeters, could be in earth, how much energy you can save worldwide. This is also a test we want to do. So you see, we are really in every small, bigger test.
Trying to optimize everything.
Yeah, and also do testing. We want to support that also from the ETH. To find also in that question answers, but also the system from Herzog Dömerow. It's possible. It's heavier then, so we have to, maybe the fundamentals has another impact, but yes, of course, you could combine all these ideas also in a high-rise building.
Good. So we have a question over here. We can get that. Here. I'm going to run it over to him. You have a mic over here? Oh, right here, for this guy in the blue, and then we can see in the back. And then we're coming close to the end of the hour, so
we'll hurry up.
Right over here.
My name is Markus Fuhrer from Baltoschiri. I've done lots of CNC milling for Erne for this building. Thank you very much, Thomas. My question is about CO2 calculation. So we are good in engineering and we are ahead of Europe. But if we do CO2 calculation with the KBOB database, Fagus thankfully has its own values in this database. But regarding to spruce, glulam, CLT, we are we have 3 times more CO2 in 1 kilo than concrete. And what do you think about that? How can we solve this issue? And are we on the right path with the KBOB database, or should we look a bit more at our neighbors in Europe?
What's the KBOB database?
The KBOB database is the Swiss database for ecological values for wood and concrete and whatever.
Okay.
One part of that.
Not everyone is from Switzerland who's here. That's what.
Yeah, concrete is heavier than wood. So if you and this is and we are 25% better instead of doing the same building with the same structure in concrete, and we have bigger fundamentals. So it's just the glue is in it, and of course you can say it would be nice to do a high-rise building without glue. This is and even more circular could be maybe a future project. Probably it's possible. But for the first step, I think it's okay.
I know that we are better, but we sell ourselves in a bad way. So
yeah,
the concrete industry
but this
do a
is
better
maybe
job
also
than we
something which we should reflect after doing this building and probably recalculate what. Maybe I'm not the CO2 calculator. I just look to my project manager if he's have a smarter answer.
Yeah, I'm not really into this KBOB database, but I just know that they are overworking the data and it will look better with the new ones. So we will calculate it again, yeah.
Okay, we're going to move the question.
Just for an example, if you do a lift shaft in concrete and in CLT, the concrete one would be better or not more, not much worse than the wooden one. Yeah, Thomas did the calculation.
Yeah, I know that problem, that if you do a core in concrete or in wood, the problem is that you need a lot of wood. The wood is dried and the wood is glued, and that raises up the CO2 emission at the end. So the question is, how can we eliminate the concrete and reduce the wood in an efficient way? And maybe for 3 or 4-story buildings, we can do it with rammed earth. And then you have a very good CO2 balance.
I think there's a good question. We can move the mic back 3 rows, and then anyone over here who's still awake that wants to give a question? If not, then we're gonna wrap up very soon. Okay, question in the back. One thing is, it's a step, right? This is the first. It's a prototype. Each time we're getting better. We learn the lessons. We learn the questions to ask. How can we keep getting better? This is what this is really about, right? And this is really about that. So it's good to ask hard questions. Yeah. You like hard questions. Yeah. All of you do, I know. Yeah. You have a great client who asks hard questions, right? So
she will do the next building then.
Yeah. A question, then I'm going to finish up.
Yes. Reinforced concrete structures are based on rigid connections between columns and plates, and that gives monolithism to the structure. And also, there is a high level of redundancy. Can we still get that with a hybrid prefab system? And if so, can it be disassembled?
Yes, and this is the unique thing of this tall timber building. It is robust because from the beginning, I insist that the topic was addressed. And the engineers with the company, they develop what Thomas mentioned, the detail, the connection. So you can remove any column in this building, nothing happen. And you can, of course, there are some maybe welded plate to be dismantled, but then you can dismantle the building. So again, this building fulfill all requirements, otherwise I would not accept, she would not accept, he would not build, and he would not accept. But this is amazing that even with the prefabrication, all elements are connecting together, of course. Just because, especially in this category of the building, you cannot accept that I remove a column. It will never happen. but we should also think this scenario and the building collapse. That's unacceptable.
So I have one question last, a couple actually. What if we look at it? I want to ask each one of you a final question before I come to the end. As an institutional investor, you took a risk, and all of us in here who have projects would love to have an investor who takes a risk with us, right? This is what do you say right now are some of the biggest challenges that you see that we might be able to step up to?
I think the biggest challenge for us is still keeping in mind all the aspects and that we have the ecological, the economical, the social aspect, and it's also the biggest challenge is maybe also for an investor to stay creative enough to fulfill all the requirements and to work in the interest of the clients and of the tenants. So that's there are so many things to think about, and that's why I think we all have to stay curious, to stay flexible, to trust the crowd intelligence, and because at the end it's all teamwork and it has to work out.
I think it's great. I mean, it's really impressive how you found a consultant to help you build your trust. Andreas, I have a question for you. We're at an academic institution, you're a professor. What piece of homework would you give all of us to take away, to think about for us?
Oh, I mean, we should just follow our dreams, of course. And
oh, come on, that's not a good piece of homework. Come
no,
on.
I mean, we want to. I mean, we have limits, and our role at ETH is to show that we can go beyond these limits. And this building is showing again that nobody was thinking to do this, and now we have done, and we have, as Roger mentioned, the next is on the planning, and so on. So we move limits because I think it's good to move these limits beyond what we think is reasonable, and but we also respect the limit. I really think we respect, and what we have done, there was also mock-up they have done behind this building. There is so much work, I have to say, just because at the end we want to be sure that everything works well. But
cool.
My message is we should continue in this way, promoting innovation, collaborating together, and showing that we have other solutions in a sector where we have done the same for the last 100 years.
I'd say the same for the past 2,000 years.
Or
That's
2,000
okay,
even, yes.
So I could almost be the final word, but I want to ask Thomas, what question did I not ask you that I should have about this building?
Which questions you should not...
What question did I not ask you that I should have asked you about this building?
How big the discussion was about the beach.
How long was the discussion about the beach?
It was a big process, a big finding process. At the end, how or is the beach it's a new product, and can we build a high-rise building with a new product of a beach column?
Mm-hmm.
So, and it was in the beginning a very big discussion. How can we guarantee that? Who want to give the guarantee? And we find the process and we do it, and now we are happy about this. So, but it was a not easy way.
That sounds like a great conversation to have over a glass of wine, actually, to hear more about that. And Roger, the final question for you is, this is clearly a very inspiring building and an inspiring process. What building or two or place do you look for your inspiration?
Often to traditional ones.
Yeah.
It's not. It's as I said. It's we have to look for new answer. It's and what we built in the last maybe 50 years are not the answers. So finding our materials and do the upscale as you found it in the tradition. And this is extremely inspiring, and it's a lot of fun. So it's also something for the students, you know. You think we have so many numbers now, we have to reflect, and we have to be CO2 efficient. It also looks a little bit, and even build is a problem today, you know. You should do reuse or don't build new. And it sometimes has a little bit a negative approach, you know, all this climate aspect. And what I think it's to look back, but out of that, think about how we can redo that with our instrument, with our smartness, what we develop at the schools, many great things that we develop at school, and how we can do a new design out of that. It's a lot of fun. It's a hard problem, but it's also a great thing to come together to discuss for a new solution, and also to do a piece of a new design, which is something I have to say I don't know a building like that, and I hope I will like it if you really see it, and I'm sure I will like it. But it's in that sense it's really new, and this is great, I think, and it should be an inspiration for the students, and I'm proud that the ETH is now thinking about an integrated first year. So we want to do an integrated first year with 8 professors integrated from all the disciplines to start with an integrated first year. Yeah. It's the first time, and this is something which is also happened, and it's inspiring to do it, you know.
That's great.
And, yeah.
Thank you for that. I think as we look back, have we heard it today that this is going to become the new normal? This is one of the new normals we'll see. And I think you've done a very convincing job for me. I've enjoyed talking with you very much. So I'd like to thank all of you for your openness, going with the conversation and sharing your insights with us. And let us thank them as we normally do with a round of applause. And before we close, let's get a couple of things. First, thank all of you for coming. I mean, you didn't have a choice. You're here, right? But you did have a choice to come, and so thank you for joining this evening's Holcim Foundation Award Talk, and that's really fantastic. Now, the Holcim Foundation Awards for 2025 will be open for submissions on the 1st of October. So, be thinking about what you might be able to submit. And it is a unique competition with a $1 million prize pool shared across 5 regions, and this was the Europe region prize winner last year. So there's a good chance of getting some money. Remember, identifying and celebrating shining real-world examples of leading-edge sustainable building practice. And more information is available. It's an advertisement. You got to do the advertisement, right? Come on. It's available regarding the awards and the other foundation activities at the holcimfoundation.org website. And I actually just perused it today. It's a good website. So we now have the opportunity to get a glass of wine and to continue the conversations. I know Harry had some questions. Stuart always has questions. I'm sure you all did too. And you stayed awake. Well done. Well done, William. And thank you very much to the Holcim Foundation for hosting this evening, and to the ETH for hosting us here in this building. And again, a round of applause for our panel and for all of you. Thank you. There we go.